again, we're trying to make the connections with AP Calculus here. Super important that you know how to solve all kinds of equations. We just throw a variety of them at you and expect that you'll be able to solve them because we have calculus things to learn next year, not algebra things. And so that's a major frustration for students whose algebra skills aren't great, is that they keep asking algebra questions, and I'll try to answer them, but we try to spend our time on calculus, not on algebra. And so this is one of those things where if you plan on going to AP Calculus, please learn this so that your life will be a little bit easier next year. All right, techniques and tips for solving trig functions algebraically, so without calculator. So no calculator today. Job 1 is to isolate the trig function. Again, today we're not going to do all of the notes and then do examples. We're going to jump back and forth a little bit because I think that'll make things a little bit better. So we'll do sort of section A there and then do some notes, and then section B, or problems, section B and do some problems, section C and do some problems. Section A, isolate the trig function. When possible, isolate the trig function. That means usually sine, cosine, or tangent, but one of the others as well. Get that thing by itself by manipulating the equation so that the trig function is alone on one side of the equation. So get sine of 2x by itself, or tangent of x over 2 by itself. Then, these are steps, they've got to go in order. Then ask yourself what the reference angle and really that means the denominator. What's the denominator? Like, is it an over 3, over 4, over 6? Is it shallow, middle, steep? For the trig function and that trig value. Three is a long blank, but use all students take calculus. All students take calculus. Or not. Like, you don't have to use that. You can know that the sine is positive on the ups and negative on the downs. Cosine is positive on the right and negative on the left. Tangent is positive on. However you know the signs, you need to know the signs. All students take calculus is one way to know that. To determine which two quadrants, right? Because they're all positive in 2 and negative in 2. So figure out which two quadrants the reference angle function must be in. And then kind of a side note, since we are solving an equation, right? Like if we have sine of x equals 1/2, how many solutions does that have? Infinite. Like, we're going to restrict it so that we don't have to list all of them or come up with a way to list all of them. But we don't want to lose sight of the fact that in reality there's an infinite number of solutions. We're not going to give them all, but there are an infinite number of them out there. So this is different than our work with inverse trig functions. Here's the little reminder picture for inverse trig functions. Some of the functions had to come from 1 and 4. Some came from 1 and 2. And you had to pick only one answer, the right answer from the right quadrant. Like, that's inverse trig functions. But we're not doing inverses today. We're looking at equations. So back to the notes here. So do not restrict the domain. You're not looking for just one answer. like we were with inverses, because these are equations rather than inverses. So use both quadrants that make the trig function have the right sign. Let's do that real quick with this little example right here. If sine of x equals 1/2, what quadrants have a positive sign? And again, you can do all students take calculus, or you could just think about it. Which quadrants have a positive sign? 1 and 2, the up quadrants. And where is the sign 1/2? Is that over 6, over 4, or over 3? Shallow, middle, or steep? The 6. So I know it's over 6 in the first and second. So that would be pi over 6 is the easy one. How about in the second quadrant? 5 pi over 6. And there's an infinite number of solutions, because you could add 2 pi to either of those however many times you wanted to. All right, that's enough of those notes. Let's do an example. So we're going to flip back and forth a little bit here. So turn the page. We're going to do number 1 and number 2. Number 1 is 8 cosine x plus 4 equals 0. Well, job 1 on all of these, and I hesitate to put 1 because I don't know that there's going to be any other steps, but job 1 is always going to be isolate the trig function. So get cosine of x by itself. So that's an algebra step. You got to move some things around to get cosine of x by itself. Now, some people will do both steps at once. Other people will show all of their work, which is fine. 8 cosine x equals -4. If I divide by 8, cosine of x equals -1/2. That's isolating the trig function. Trig function isolated. Mission accomplished. Well, mission accomplished, but the problem's not over. Now I can just start to think about, okay, where is the cosine negative? So I guess that's step number 2 is, well, it could be 2 or 3. I do the quadrants first. So cosine is negative on the left. Your left. So that'd be 2 and 3. You don't have to write this out, but maybe it helps. So in quadrants 2 and 3. And then the last step would be, what's the denominator? And by that, we basically mean, is it the shallow, the middle, or the steep? So I know I'm in quadrant 2 and 3. What would make the cosine equal to 1/2? The shallow, the middle, or the steep? The steep, because we want the x value to be 1/2. So I'm going to be steep. 4 pi over 6 is right, but that's not usually what we say.
Sorry, I'm just thinking 6.
So if it's steep, that means the denominator is 3. So something over 3 and something over 3.
Oh, we did this.
We've kind of done this.
We did this again.
When we did it with reference or with inverses, we only were allowed one answer, right? We could only look for the easy answer. Now we're looking for all the answers. So over 3 in the second quadrant, that would be 2 pi over 3. And over 3 in the fourth or the third quadrant, it would be 4 pi over 3. because cosine is negative in second and third. At the over 3 mark, at the steep angle, the cosine's 1/2, and so then you figure out, well, exactly which angles are those.
Do you also make note of the negative answers?
You mean like if we went this way to get there?
Yes.
No, because it's a good question. Do we make note of the negative? So like, yeah, if we went backwards, negative 2 pi over 3, that is sort of an answer to the equation, but since it said 0 to 2 pi, we wouldn't use that one. Okay, does that answer your question?
Yeah.
So negative 2 pi over 3 solves the equation, but we said, no, we only want 0 to 2 pi. Jason?
Would there be a situation where it would be like the greater than and equal like are backwards, and it would be you have to do the negatives? Would there be like a trick like that?
No, I mean there could be. Like I could say find the answers from negative 2 pi to 0.
Yeah, it wouldn't be hard. I would just.
And then you would have to give the negative ones
Yeah.
and not the positive ones.
So that's why it can't be negative.
Right.
Because if there's sign.
Because of this. The negative 2 pi over 3 works in this equation. But we've eliminated it from our range of possible answers.
Okay.
Ty?
So I understood it all besides the part that told you it was steep.
Okay, that goes back to unit circle stuff. The cosine is 1/2 at pi over 3. Because cosine is the x length is the short side. That happens at pi over 3. That's a unit circle thing. So, yeah, back to the unit circle. Number 2. Why don't you try step 1 on number 2 on your own. So step 1 is isolate the trig function. So you actually got 2 of them, so I need this to take a little bit more work. See if you can isolate the trig function for number 2. And then the long way around to quadrant 4 would be 11 pi over 6.
Instead of it being negative 1 pi over 6. And
Correct.
negative 4 pi over 3.
So yeah, negative pi over 6, you're like, is that a right answer? Depends on what you mean by right answer. Does it solve the equation? Yes. But
It doesn't follow through that.
it doesn't fit where we said we were allowed to look. This happens a lot in calculus, not like this type of problem, but a lot of times we restrict and say, hey, between 0 and 2, find whatever. And sometimes you get an answer that's 4, and you're like, well, doesn't matter. I'm not allowed to look there. So we need to get used to seeing that. A lot of times in math, we see that and we're like, oh, that doesn't really matter to the problem. I'll just ignore it. Like, no, it matters, especially here. Okay, so those are kind of the straightforward ones. Let's do, if you look at 3 and 4, you tell me what makes 3 and 4 different from 1 and 2.
It doesn't have, right now.
Yeah, the x has a coefficient. So that's different. So let's flip back to the notes and talk about what happens if x has a coefficient. In fact, that's the name of B. Trig arguments with coefficients. Meaning sine of 2x equals 1/2. Okay, so this is a little bit of a trick. Treat the 2x like a single angle. In fact, it might be helpful to put it in parentheses. Like that's one thing. Don't worry about the 2 yet. Let's worry about 2x. We'll handle the 2 at the very end. It's basically what we're going to do. Set the 2x equal to the angles that make the sine equal 1/2. Solve the problem like normal, but instead of x equals pi over 6, you're going to have 2x equals pi over 6. So basically hold off on the coefficient thing till the very end. Then at the end, sort of after you've done the pre-cal, after you've done almost all of the problem, then divide by that 2, or whatever the coefficient is, to get the x values. basically save the 2 for the end and then divide by 2. However, number 4, when you divide by 2, this only gives you the x values between, well, let's see, we started off as 2x between 0 and 2 pi. If we divide everybody by 2, you end up with your answers between 0 and pi. It's like, so your answers aren't wrong, they're just not all of them. So they're good answers, it's just not all of the answers. To get the remaining, meaning from pi to 2 pi, it's like the grammar's not quite right there. The remaining angles from pi to 2 pi, you got to go back and find more angles before you divide by the 2. This will make more sense when we do one of these problems, I think. If the coefficient is 2, this is a little bit of a trick that you don't have to know this last statement, but it's going to make life a little easier if you do. If the coefficient is 2, then you end up with double the number of angles. So usually we have 2 answers. If there's a 2x, you got 4 answers. If the coefficient is 3, what do you think will happen to the number of angles? Triple. 4, quadruple, 5, quintuple, etc., etc. We're not going to go that far because then you end up with too many answers. To get more angles that work, how do we usually get more angles that work? How do we end up at the same spot on the unit circle? What do we add to land at the same spot? 2 pi. So we'll add 2 pi before we divide. I wish it had said that. Before we divide. Again, we divide at the very end. Oh, I guess it sort of says that. Then divide. So add 2 pi, then divide both sides by the coefficient. Okay, that's a lot of words. Let's go do number 3 and 4. So at the top, isolate the trig function, handle the quadrants, think about the denominator, then, sort of if necessary, I think I spelled that right, then we'll handle the coefficients. That's sort of the hard part. So number 1 and number 2 didn't have that, so that made them easier. 3 and 4, there's a coefficient in there. Now, we're still going to do steps 1 through 3. So if we look at number 3, job 1 is to isolate the trig function. So tangent of 2x equals 1 over square root 3. Bit of a side note in this one, I don't like 1 over the square root of 3. Let's fix it, because then it looks like a unit circle value. Square root 3 over 3, so that's better looking.
I thought you would square both sides, wouldn't you? Or you would just move it?
So if you squared both sides,
Because if like this,
you would get 1/3 on the right hand side.
yeah.
1/3 is better looking than 1 over square root of 3. I will grant you that. But if you square both sides, what do you have on the left side? Tangent squared.
Okay.
I don't want to deal with tangent squared.
So you just move.
So it would be legal, it just wouldn't be helpful.
Okay, so you just moved this square root.
So I just moved it over.
Okay.
And you're right, you get here, square both sides, you get a nicer looking right hand side. But you have a terrible looking left hand side. So don't do that. Alright, we isolated. Now we want to think about quadrants. Again, we saved the 2. Like, I'm wary of this 2, but I don't worry about it until the end. I save it for the end. So I'm back to isolating, and then I'm thinking quadrants. So where is the tangent positive?
On like the right side. Wait, no, it's like corners, I guess.
Corners,
1 and
yeah.
3.
All students take calculus 1 and 3.
1 and 3.
And then I'm thinking about denominators. So, or shallow, middle, steep. That's the same thing. Do you remember the tangent 3 trick?
Yes, 2 3s and over 6.
If it's 2 3s, it's over 6. So my answer is over 6 in the first and third. So that's pi over 6 and 7 pi over 6. Now, here's where I need to slow down and be super careful, because my answer isn't really pi over 6 and 7 pi over 6. This is where 2x equals pi over 6 and 7 pi over 6.
But don't you want to double the amount first?
But I need to double the amount, so I'm not through. You know, if I divide by 2 here, I get 2 answers. They're not wrong. This is not all of them. I need to come up with 2 more answers.
13 pi over 6.
So I need to add 2 pi. Again, some fraction knowledge would make this a little quicker. If I add 2 pi, somebody said it, 13 pi over 6. And if I add 2 pi to 7 pi over 6, the common denominator, I get 19 pi over 6. This kind of, there's a lot of stuff going on, and the more you're able to do in your head, or the more you're able to understand, the easier this is. Like adding fractions. Like if you have to go off to the side to add 2 pi, that's fine. But man, that means you got to work over here, not make any mistakes. Come back to the main problem. If you can add 2 pi without going off to the side to do it, that would be great. All right, again, the 2 meant we need to double our answers, and we did that. And now we're almost done. If I have x equals 2x equals all these things, what do I do to get x by itself? Divide by 2. What's another way to say divide by 2?
Multiply by 1.
Multiply by 1/2. I mean, I can divide by 2, but I'd rather multiply by 1/2. I'm out of colors here.
Pi over 12.
So they're basically going to be all over 12.
Yeah.
Multiply by 1/2 to get rid of that 2 on there. And so, yeah, they're all going to be over 12. Pi over 12, 7 pi over 12, 13 pi over 12, 19 pi over 12. You can kind of do a check on your answer. All of those should be between 0 and 2 pi. So maybe I should check that last one. 19 over 12. Is that less than 2? 19 over 12?
Yeah, it is.
Yeah, because 24 over 12 would be 2. So that's less than 2 pi. So I feel like all of my answers are in my range. So I'm good with those answers. Let's try number 4. Now we got a 3 in there. First 3 steps are the same though. Isolate. Oh, and I guess fix it maybe. So it looks like a unit circle value. Root 2 over 2. I'm definitely worried about the 3, but I'm going to hold off the 3 till the end. So then I'm thinking quadrants. The quadrants and the denominators kind of go together if you want to draw the picture. Cosine is positive on the on that side, on the right,
Yeah.
1 and 4. Again, if you don't know the numbers, it doesn't matter as long as you know that it's in those two over there, because that's where cosine's positive. If you need all students to take calculus, that's fine. That's not really how I emphasized and used the signs, but it still works. All positive and cosine's positive in 1 and 4. Root 2 over 2, which denominator does that happen at?
Middle.
The middle, so the over 4s. So that would be pi over 4 and 5 pi over 4. Yep. Why? No wonder you're looking at me funny. Like, why is he drawing in quadrant 3 when he said quadrant 4? So over 4 in the fourth quadrant would be 7 pi over 4. So something equals pi over 4 and 7 pi over 4. But what equals pi over 4 and 7 pi over 4?
3x.
The 3x. So again, I haven't handled the 3 yet. I need to add 2 pi. So let's see. So that would be 8 pi over 4. And I'm going to skip one so that I put them in order. If I add 8 again, I get 17 pi over 4. And if I start with 7 and add 2 pi over 4, I get 15 pi over 4. And add 8 pi over 4 again, 23 pi over 4. How do I know where to stop? Like, why don't I just keep adding 2 pi forever?
Because that's how much you have to do.
That's how much you got to do. 3x meant you get 3x the number of answers. You get 3 times the number of answers as you originally had. So I thought there were 2 answers, but the 3x means I need sort of 3 sets of answers. And then now what do I do? And how do I let's multiply by 1/3. And that'll just make all the denominators 12. I see some
stuff that can be simplified.
I see some simplifying that can happen. So I kind of just blitzed through that and made all the denominators 12, which wasn't wrong, but 9 pi over 12, that's 3 pi over 4. And rather than rewrite them all, I think I'll just reduce those. And divide top and bottom by 3, 5 pi over 4. So be careful, you may get something that can reduce.
Would it be counted off if it wasn't reduced?
Yes, but only like 1. I mean, that's probably like a 5 or 6 point problem, and you got the vast majority of it right. So I'm not going to take off half if you didn't reduce. Okay, we can pass on number 5 for now. Thank you. So back to the notes side. Using the inverse trig function key on your calculator. So back to the calculator, but this is, well, there's 2 ways to do it, and I'll show both, and you can figure out which way you like. It's worthwhile to mention the inverse trig capability of the calculators. Right, when you do second sign, that gets you the inverse sign. You can use this key. The trouble is the calculator can only give you one answer. right? Like he can't give you, like we just had one with 8 answers, right? 6 answers. The calculator can't give you 6 answers. It can only give you 1 answer. And then you would have to find the other values. Would the other values be easy? Well, maybe, maybe not. It kind of depends. Using all students take calculus, and I'm not sure the best thing to put in that blank. The key says logic. I'm going to say properties or graphs. Like it's going to take some thinking to figure out what the other answer is. Which is why most people are going to say, or you can use the graphing technique that we did yesterday to find all the values at once, and then you don't have to worry about it. So let's pass on number 5 and instead jump to the worksheet, because this happens at number 11. Okay, so 2 methods. Method 1, x equals inverse sine of 0.527. So this appears to be the easier method when you start off. Okay, but how many places have a positive sign on the unit circle? Or what quadrants? Let me back up. What quadrants have a positive sign? And we just found the first one. That's that one.
Is it always going to find it in the first quadrant?
It's always going to find the easiest one, like when we did it. It uses the restrictions that we learned.
Okay.
The calculator knows those restrictions. So if there's a first quadrant answer, it'll be in the first quadrant. But how do I find the other one?
Good luck.
Good luck. One answer is use the graphing part, but the other answer is, like, I know they're symmetrical, so I know that angle is also 0.55. Although that's weirdly measured.
Yeah. I mean, slightly less now.
So how can I figure out what this angle is? Okay, it's 180 degrees. So in radians, that is pi. So all the way is pi, but I'd want to back up 0.555.
And that's it? Or do you just, you actually have to? Oh, because your answer must be pi, between pi and 2 pi. That's what 6.283.
Correct. So it's like, well, which way is easier? Well, if you can think about it, it's quicker to do this, but that's a lot of thinking. If instead you want to use the calculator method, then you would do sine of x, this is what we did yesterday, minus 0.527. And this better give me those same 2 answers that I just found. I'm really concerned about that second one. I'm not worried about the first one. I'm concerned about that second one. So second calc, intersection, first curve, second curve. Yes. I'm not worried about the first one. If I get the second one right, I'll feel confident. 2.587. So I feel good about my answer. Either one of these methods is fine. So like if you understand it, the first method's quicker. But if you can't come up with that second answer, then you'll have to graph it and come up with the second answer.
Can you check the first one?
I can check the first one that way as well, since I'm here. Second calc intersect. First curve, second curve. And then let's go check the first one. 0.555.
Okay.
I mean, when that one checked out, I was pretty sure I got the first one right because the second answer depended upon the first answer.
Yeah.
But if you don't want to use that method at all and you just want to go to the graphing because that way they all work the same, that's fine. That's why we don't spend a whole lot of time on that. It's like if you got to use the calculator anyway, then you can just do the graphing method and not have to worry about it. All right, so worksheet 2 is the assignment. It's only one page, but obviously there's some 3x's and 2x's that require some thought.